Okay, so as we begin, as I previously said, you all have had this study guide for 2 weeks. As we went over the assignments, I told you the ones that you should have been able to complete at that time. You all have had unlimited attempts at doing the study guide, which means that you could have submitted it unlimited times, 100, 200, 300, 400 times. If you submitted your study guide only one time and you did not attempt to correct your answers, that's because that you were pleased with the grade that you got. Whether it was an F or an A, you were happy with what you got and you did not put forth effort to resubmit it again. You all also were informed that if you did not have computer access, you could have submitted your study guides in class when you arrived in class every day so that you could see it. That means that you would have had to go home, work out your problems on your paper, come in class, open up the file to submit your documentation. Also, those of you who did not submit your study guide online, you already knew that your paper copy would be submitted and you would not have unlimited attempts on resubmitting that. Are there any questions about anything that I said or a discrepancy in the things that I stated? Awesome. So today I will upload the key that I have in my hand. Again, what I wrote on your paper is what you were taught. On my paper is what you were taught in class as we completed IXL. The work that I show is what you should have shown on your paper. So if you get home and you see that you didn't have anything or you're sitting there and you don't have it, I'm going to write it on the board as we go over it right now, as well as upload a paper copy of this. You all will have access to this video online, and if you're wondering where it can be found, when you go into Google Classroom, go to classwork, you're going to scroll down. Everything pertaining to study guide will be posted under probability study guide. Again, here's where your extra copy, Google Docs, is the copy that you could have printed at home if you lost yours, although I've given out copies after copies after copies. The Google form is where you submit your answers, and it's where you can also edit your answers. All of this has previously been discussed in class. Any questions moving forward? Okay, so the first question says the probability of a newly released movie being on Redbox is 3 out of 8. About how many movies will be on Redbox out of 64 new releases? So they give us the probability, the experimental probability, and all you have to do is multiply that by what the question is asking you about, which is how many will be out of 64 new movies. This is your theoretical probability. So you simply say 3 over 8 times 64. This will give you 24. All you have to do is put 3 divided by 8 in your calculator, hit enter, times 64, and it will give you 24. Are there any questions here? Any questions? Yes. Cross multiplication is fine. So if you set it up like this, we'll do the division line. What is 3 times 64? How many? 192. You still will have x as 24. Either way is fine. Okay. Any questions here? That's the work that you show. Any questions here? Okay. Moving along. In our next questions, it tells us to use the spinner, and this is a 2-part question. The first one says the ports are labeled A through B. You use it for ports A and B. We have a spinner with RBGW, and then we have a spinner with 1, 2, 3, 4, and 5. The first question says, what is the probability of a student spinning a 2 or a 5? So on our spinner with numbers, we have a total of 1, 2, 3, 4, 5. 5 numbers. 2 or 5. How many numbers are 2 or 5? That's 1 and 2. So the probability would be 2 out of 5. Any questions here? Okay. What are the chances of a student will spend a color that is not white? Well, we have a total of 4 colors. 3 of those colors are not white. That's about 75% of those that are not white. So that is very likely that we will spend a color that is not white. Any questions here? Any questions here? Okay, moving along. On to number 3. Customers at a candy shop can choose the type of candy and the color they want to buy. The table shows the candy bought on a given day. So we have blue Sour Patch Kids and blue gummy worms. We have orange Sour Patch Kids and orange gummy worms. We have green Sour Patch Kids and green gummy worms. It says, what is the experimental probability that the next customer will buy a pack of blue Sour Patch Kids? Well, the first thing we need to do is determine our total. Now, when we're determining our total, we need to add all of these numbers, this set of numbers and this set of numbers. Our total is 40. So the total number of candies that we have is 40. Okay, so in our question, it's asking about blue Sour Patch Kids. So we have 12 blue Sour Patch Kids. So the probability of getting a blue Sour Patch Kids is 12 out of 40. Okay, this can be reduced by dividing by 4, which will give us 3 over 10. This is our answer, which is A. So the answer for number 3 is A. That's the work that you should have shown. Any questions? Any questions? Okay, moving along. The chart shows the team batting averages for 7 weeks while playing 3 games. They played 3 games for 7 weeks. Based on the information in the table, what is the experimental probability that the team will bat above .300 in tomorrow's game? Make sure your answer is in reduced form. So there are a total of how many games? Let's see, they had 3 games for 7 weeks. That's 21 games. So we're looking at the games. If you're not sure how to do that, you can simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 games. We are not finding the total batting average. We're looking at the number of games. So we're looking for the ones that are above .300. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 games that were above .300. So that's 10 over 21. And that is in its simplest form. So our answer here is A. Any questions here? Any questions here? Okay, moving along to our next one. So a groundhog has predicted we would have a longer winter 103 out of 120 times. How many times will we have a longer winter if we let the groundhog predict 600 times? So they already gave us our experimental probability. that the groundhog has predicted 103 out of 120. So we're going to say 103 over 120. Now, that's the probability with 120. To determine if we let the groundhog predict 600 times, you just simply multiply it by 600. Yes, you can cross multiply, that is fine. But 103 divided by 120 times 300 will give you 515. Your answer is 515 times out of 600. So 515, that's how many longer winters we will have. Any questions here? Any questions? Any questions? Are you writing what I'm writing down? Okay, moving along. Now we're going to use this spinner to answer parts A through C. The first one asks about sample space. Sample space are all of our possible outcomes. Remember, with sample space, we only list them once. List only once. Okay. So we have a 1, 2, 3, 4, and 5. So we have, again, 1, 2, 3, 4, and 5. Our sample space is C. Any questions here? Okay. So, what is the probability that the spinner will land on a 5? What is the probability that the spinner will land on a 5? So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. We have a total of 12 numbers. Of those 12 numbers, 4 of them are 5. That's about 33%. So it is unlikely that it will land on 5. 33%. You can look on the front page of your notes to look at that chart to see the likely and unlikely and certain and so forth. In the next question, it says, what is the probability that the spinner will not land on 3? Will not land on 3. So you are looking for numbers that are not 3. In the set of numbers that we have again 12 numbers. 9 of the 12 are not 3. This can be reduced, which will give us 3 over 4. So the probability of landing on a number that is not 3 is 3 over 4. Any questions here? Any questions here? Give y'all this. Okay, moving along to number 7. And some of these problems you may have to read more than one time to ensure that you are getting the correct answer. If you all notice, I do a lot of writing. So if Ms. Godfrey is having to write to come up with the correct answer, I'm pretty sure you all are too. So on number 7, we're talking about cars. So there are 14 sedans, 6 SUVs, 8 trucks, 6 convertibles in the parking garage. Which of the following is not? We're looking for the one that is not a true statement about randomly selecting a vehicle out of the garage. Now, what I did so I can look at it a little bit better, I start using my pencil. So the probability of choosing a sedan is more likely than choosing a convertible. So we have 14 sedans. We have 6 convertible. We're trying to see if this is a true or false statement. We're looking for our false statements. So is the probability of getting 14 more than getting 6? That is true. So we know this one is not the correct answer. The probability of choosing a convertible, which is 6, or a sedan, which is 14, is more likely than choosing a truck. A truck is 8. So is 20 more likely than 8? Yes. So guess what? This one is true. The probability of choosing a convertible, 6, and an SUV, which is 6, is the same as choosing a sedan, which is 14. Is 6 and 6, which is 12, is 12 the same as 14? No. And let's also double check our last one. The probability of getting an SUV is the same as choosing a convertible. Is that one true? Yes, 6 and 6 are the same. If you notice, I made notations on there, compared my numbers. Any questions here? So on to the next one. We're talking about fish in our next problem. Landon has 12 goldfish and 12 clownfish at his house. Landon is going to randomly choose a fish to have its own cage each night. Which statement explains how to find the probability that Nemo, a clownfish, will be the fish that he picks? So when we're setting up probability, what goes on the bottom? The total. So we will have the total of all fish on the bottom, and then what we're looking for on top. All right. So the denominator, which is our bottom number, is the total number of clownfish, and the numerator is represented by Nemo because he is the only fish being considered. So what type of fish are we looking at? Well, they told us we had goldfish and clownfish. So our denominator is the total number of clownfish. Is that true? No, because it has to be the total number of clownfish and goldfish. That makes this one incorrect. So the denominator is the total number of goldfish and clownfish. That part is correct. And the numerator is the goldfish because all fish are being considered. Well, in our question, it actually says the probability of getting Nemo. So Nemo is the fish that's being considered. This is why this part is incorrect. The denominator is the total number of goldfish and clownfish. That part is correct. And the numerator is represented by Nemo because he is the only fish being considered. That is correct. Let's look at the last one just to cancel it out. The denominator is the number of clownfish. Nope. The denominator should be the total number of fish. That is incorrect. So this one is wrong as well. So C is our correct answer, and I did my justification on my paper. And also this part is also incorrect. The numerator is the number of goldfish. That is incorrect. It should have been Nemo because that's what's being considered. Any questions with this one? Any questions with this one? All right. Moving along to number 9. This one is asking about likely to occur, neither likely or unlikely, are unlikely. So for me, it was easier for me to change my fractions into percent. So 9 over 12 is 75%. 5 over 10 is 50%. And 3 over 8 is 37.5%. If something is at 75%, it is likely to occur. If it is at 50%, it's 50-50, neither likely or unlikely. And if it's at 37.5%, that is below midpoint, so it is unlikely to occur. Any questions here? Any questions? Okay. Y'all can close your Chromebooks. I don't want any distractions. Thank you. Okay, so on our second part, not our second part, on number 10, this is exactly like DD 9 and maybe DD 7 and 14. One of the ones we've done, and also the ones that came from your ICANN check. And just like number 1 as well. So a cube has 6 sides numbered 1 through 6, and is rolled 1,920 times. Let me reread that one. A cube has sides numbered 1 through 6 and is rolled 1,920 times. How many times would you expect the results to be an odd number greater than 4? So the first thing I need to determine is my experimental probability, because I probably can't roll it 1,920 times. So some of us struggle with knowing the numbers that are on a cube. Take out the time to write them down. 1, 2, 3, 4, 5, 6. Odd numbers greater than 4. We only have one odd number that is greater than 4. That's 5. So the probability, the experimental probability of getting an odd number greater than 4 is 1 out of 4. Now we're going to multiply that by what our question is looking for. If we did it 1,920 times, 1 over 4 times 1,920 times is 320. Any questions here? Your answer is 320. Okay? So on the second part, still using the 1,920, they're looking for numbers less than 3. Numbers less than 3. So we have, again, on our number cube, we have 1, 2, 3, 4, 5, and 6. Numbers that are less than 3. We have 2 numbers that are less than 3. So that will be 2 out of 6. That's our experimental probability. We're going to multiply by what we're looking for. If we rolled it 1,920 times, that will give us 640. We can expect that we will get a number less than 3, 640 times, if we were to roll this cube 1,920 times. Any questions here? Any questions here? Any questions? Okay, moving along to number 11. Number 11 is about donuts. This is a dependent probability problem, such as numbers DD 9, 10, and 11. Daryl and Dunny buy a box of a dozen donuts. If you don't know, a dozen is 12. A dozen is 12. So he bought a box of a dozen donuts. 7 of the donuts are glazed, 3 are chocolate, and 2 are vanilla glazed. Without looking, what is the probability that Daryl choosing a plain glazed donut, eating it? He's not going to put it back, he's going to eat it. And then Dunny choosing another plain glazed donut. So what Daryl does is going to impact the outcome of what Dunny does. So we had a total of 12 donuts, and we're looking for a plain donut in the first event. So we have a total of 7 plain donuts. That's the first event. We know we have to multiply that by our second event, which is Dunny choosing a plain glazed donut. So because there are 8 we now only have 11 donuts for Dunny to choose from. And of those 11 donuts, 6 are plain glazed because Dunny ate one. So we're going to multiply event 1 times event 2. 7 times 6 is 42. And then that's going to be over 12 times 11, which is 132. This can be reduced starting with 2 if you want to. There is a larger number that you can use. That's 21 over 66. We can reduce it again by using 3, which will be 7 over 22. That is our probability. So your answer here is 7 over 22. Any questions here? Any questions here? Any questions? Okay, moving along to our next question. Number 12. It says 3 events, but we know we have 4 of them listed, so this should be 4. That's 4. 4 events are listed below. Check the event below that are dependent. Remember, a dependent event is one that will impact the second event. So Julie draws a card from a deck of cards. Keyword here, replaces it, and then draws another one. If she replaces it, it is an independent event. So that one is not dependent. James draws a card from a deck of cards. His friend draws another card from a deck of cards. So when James drew his card, he started off with 52. Once he drew his, he is now down to 51. So that impacted what his friend had to choose from. That is a dependent event or probability. This young lady pulls 1 marble from the bag. She sets it aside. That means she removes it. Then draws another one from the bag. Because she set it aside, this is a dependent event. And Yacinda spins a spinner, then rolls a dice. Those are 2 different items, so that one is independent. Any questions here? Any questions here? Okay, moving on to the next one. Kathy conducts an experiment in which she placed red, yellow, blue, and orange pieces of paper in a hat and drew them out without looking. The number of times Kathy drew each color is shown in the table. Based on her experiment, what is the probability that the next slip of paper Kathy draws will be red? Well, how many times did she draw? Look at your frequency. All you have to do is add that up to get your total. And the total is 55. So her total here is 55. So now we're going to take that information and we need to know how many were red. So 10 out of 55 were red. This can be reduced. So 2 over 11. That is the probability that the next slip of paper Kathy draws will be red. That's 2 out of 11. Now, probability again is always given with 2 numbers. That's a numerator and a denominator. So make sure you don't put just 2 on there. We need 2 over 11. Any questions here? Any questions here? All right, moving along. Abigail has a box that contains cards of the same size and shape. There are 6 yellow cards, 3 red cards, and 1 green card. Part A says what she draws a card at random, replaces it, and draws a second card. What is the probability that both cards will be yellow? The first thing I do, always do, same procedure every time, is to find my total. She has a total of 10 cards. A total of 10 cards. So the first event is pulling a yellow card. She has a chance of 6 out of 10 of getting a yellow card. She's going to put that card back, which means that in her second event of pulling a yellow card, she's going to start off with 10 cards. Of those 10 cards, 6 of those are yellow. We are now going to multiply event 1 by event 2. That's 36 over 100. 6 times 6 is 36. 10 times 10 is 100. This can be reduced by using 4. That will give you 9 over 25. This is your answer. 9 over 25. Okay? Any questions here? Any questions here? Okay, what is the probability that she will draw a red card, not replace it? Key thing here is not going to replace it, and then draw a green card. So we're going to first look at our first event, which is to draw a red card. Again, we have 10 cards. Of those 10 cards, 3 of those are red. Our second event, we're not putting the card back, so we only have 9 cards to work with now. Of those 9 cards, 1 of them is green. We're going to multiply our first event by our second event. So that will give us 3 over 90. Why are you talking? Be quiet. Okay, this can be reduced. 3 over 3, which will give us 1 over 30. That is your answer for part B. 1 out of 30 chance of that happening. That is a 3. Any questions here? Any questions? Any questions? Okay. On to number 15. Number 15, we have 2 spinners, which are shown here. If both spinners are spun at the same time, what is the probability of spinning a B on both spinners? Well, that's 2 different events, and we know if we have 2 different events, we need to multiply those. So the probability of spinning a spinner on our first spinner is 1 out of 4. We have a total of 4 parts. 1 of those is a B. On our next spinner, we have 3 parts, and we have 2 that are B's. So the probability of spinning a B on our second spinner is 2 out of 3. We're simply going to multiply those 2 probabilities. 2 times 1 is 2. 4 times 3 is 12. This can be reduced, which will be 1 over 6. The probability is 1 over 6. Any questions here? Any questions here? Okay, moving along to the second one. On to 16, not the second one. A coin was tossed, and a spinner with 3 equal sections, numbered 1 through 3, was spun. The results are shown in the table. What is the experimental probability that the next toss and spin will result in 3 and a tails? So the first thing we need to do is find our total. We're going to add all of these and all of these, which will give us a total of 354. And we're looking for the one that is going to be a 3 and tails. So 3 and tails, which will give us 62. 3 and tails. So that will give us 62 over 354. This can be reduced using 2, which will give us a probability of 31 out of 177. Any questions here? Any questions here? Any questions here? Okay, on to the next one. It says a spinner and a fair corn. That's not what it says. A spinner and a fair number cube are used in a game. The spinner has an equal chance of landing on one of 4 colors: red, purple, blue, or green. Here are our colors. The faces of the cube are numbered 1 through 6. What is the probability of a player spinning the color red and rolling a 5 or 6? So again, if you're not sure about what numbers are on the cube, that's 1, 2, 3, 4, 5, 6. We have 6 numbers. So our first event is, what is the probability of a player spinning a red? Spinning a red, event 1. So we have 4 colors. The probability of getting red is 1 out of 4. Our second event is rolling a 5 or a 6. Well, we have 1 5, 1 6. That's 2 out of 6 numbers meet that criteria. So that is 2 over 6. We're going to multiply these events, which will give us 2 over 24, which can be reduced by using 2. And that will give us 1 over 12. Your answer here is 1 over 12. Any questions? Any questions? Any questions? Any questions? Okay, moving on to the next one. We are flipping a coin. Typically, when you're flipping a coin, you can use a tree diagram to find your probabilities. So in the next one, it says you flip a fair coin 3 times. What is the probability of flipping at least 2 heads? So I'm going to do a tree diagram. So the first time I flip this coin, and I'm flipping it 3 times. First time I'm going to get heads, and I can get a tails. So when I flip it the second time, I can get heads or tail. It has to come off of each of the previous probabilities. So that's a head or a tail. You can get a heads or a tails. That's the second flip. We're going to flip it one more time. I can either get a heads or a tail. That's going to come off of each of the previous probabilities. So that can be a heads or a tails, a heads or a tails, heads or tails, heads or tails. This is your 3 flips and your tree diagram. Our first layer that we did was the first flip, the second is the second flip, the third is the third flip. Use your bottom and last layer to determine how many did you have in all. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8. We have a total of 8 outcomes, and we're looking for the ones that are heads. So we have 1, 2, 3, 4. We have 4 out of the 8 are heads. This can be reduced, which will give us 1 half. 1 half. Any questions here? Any questions? Okay, moving along. Marcia has a blue purse, red purse, white purse. She also has a brown shoe, black shoe, and a blue shoe. Make a list of all the possible combinations of her purse and shoes. How many possible combinations or outcomes are there? Now, this is sample space. We did this with the cereal as well as with the classes. So she has a blue purse, red purse, white purse. That's 3 options. She has a brown shoe, black shoe, and blue shoe. That's a total of 3 options for her shoes. How many outcomes should we come up with? 9. Multiply them together. So now we're going to list them. We're going to list them. So this is blue purse. I'm going to shorthand it. We can do blue purse with black shoe. I'm going to change that because we have several ones that we use. So we can do a blue purse with a brown shoe. We can do a blue purse with a black shoe. We can do a blue purse with a blue shoe. Okay? We can do a red purse with a brown shoe. A red purse with a black shoe. You can do a red purse with a blue shoe. Or we can do a white purse with a brown shoe. We can do a white purse with a black shoe. We can do a white purse with a blue shoe. Those are all of our combinations. Let's see how many we have. 1, 2, 3, 4, 5, 6, 7. Did I just count? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a total of 9 combinations, which I had up here. Any questions here? Any questions here? Okay, moving along to the next one. On this one, this is the simulations question. Remember, simulations are done. We cannot always do the actual experiment, so we want to find something that will give us a similar probability or similar outcome. So you randomly guess the answer to 4 true or false questions. You want to design a simulation you can use to model the simulation. Which tool below would be the best for the simulation? Well, true or false question has how many options? 2. You got true or you have false. Those give us 2 options. Well, a 6-sided cube gives us 6 options. That's too many. A coin gives us heads or tails. That is our correct answer. A standard deck of cards, guess what? That's 52 options, too many. And a spinner with 3 equal parts, that's going to give us 3 options. So, our 3 outcomes. So, the correct answer here is flipping a coin, or a coin can be used for the simulation. Give us 1 out of 2 options to fall on. Any questions here? 2 outcomes. Looking for the one that gives us 2 outcomes. Okay, moving along to number 21. This one here tells us that we have 3 fair number cubes. We have 3 fair number cubes. We're not rolling a 3. We have 3 fair number cubes. For each number cube labeled 1 through 6, what is the probability that all 3 number cubes will land on an even number? So we have 3 number cubes. They're labeled 1, 2, 3, 4, 5, 6. We have 1, 2, 3 even numbers. Okay? So that is 3 out of 6. It can be reduced to 1/2. So the probability when we roll our first cube of getting an even number is 1/2. When we roll our second cube, it is 1/2. When we roll our third cube, that is 1/2. These are multiple events, which means that we need to multiply each of the probabilities together. So 1 times 1 times 1 will give us 1. 2 times 2 is 4. 4 times 2 is 8. So our probability that all 3 cubes will land on an even number is 1 out of 8. Your answer here is 1 out of 8. Now you could have said 3/6 times 3/6 times 3/6, but you would have had to reduce. Any questions here? Any questions here? Okay, moving along to our next one, number 22. Select all the tree diagrams that show all outcomes for flipping a coin and rolling a number cube. Please make sure you all slow down and read this one, because even myself, as well as many others, thought it said select all 3 diagrams. It's all tree diagrams of flipping a coin and rolling a number cube. So if we have a coin, we know we have 2 possibilities, heads or tails. A number cube has 6 possibilities. So if we started with flipping a coin, that will give us heads or tails. And we're looking for a tree diagram, so we know this one is completely out. We can get heads or tails, which are C or D. Move to our second event of rolling a cube. We have 6 options. This one here only has, it has 6, but they did not put the 6 with each one of the previous outcomes. So this one is the correct one. We can have heads or tails, and then we can have 1 through 6 for heads and 1 through 6 for tails. C is correct. If we started off rolling our fair number cube, we can have 1, 2, 3, 4, 5, or 6. So that part is right. And then if we flip a coin, we can have heads or tails, but it has to go with each of our previous outcomes. A only puts 1 outcome of our second event with the previous outcome. So C and B is the correct one. Any questions here? Any questions here? Any questions? Okay, moving along to our last one. A simulation was created and the results are presented in the bar graph given. Determine the experimental probability of rolling a number greater than 4. So here we rolled 1 48 times, 2 53 times, 3 50 times, 4 52 times, 5 49 times, and 6 48 times. Our total number of rows is 300. Okay? So we know when we set up our probability, 300 is going to be on the bottom. So we're looking for the ones that were more than 4, which will include 5 and 6. So the total number of times we rolled a 5 or a 6 is 97. This is in its simplest form. 97 over 300 is your answer. Are there any questions here? Are there any questions here? The video, this particular video will be posted, or one from the other classes. I'm going to go over it with each class, so they should be the same video. They will be posted, or it will be posted in Google Classroom under Probability Study Guide. The answer key, which I'm holding in my hand that also shows the work, will be posted in Study Guide, in the Study Guide section on Google Classroom. Everyone has a copy, paper copy of the study guide. Your first test is tomorrow. You all have had this study guide for 2 weeks. You were given directions last week to work all of them except for 5. So last week you should have worked and reworked 18 of those, and then we went over independent and dependent, which were only 5 questions on Monday of this week. So you all have this material for you to study. If there are no further questions, we're going to end this video, and you all will have time to